Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 39 in our incredible new tutorial series where you are learning how to drive AI on the edge. What I will need you to do is pour yourself a nice tall glass of ice cold coffee. That would be straight up black coffee poured over ice. No sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this most excellent series of video lessons. And in this class, we will be using the AI Fusion Lab Kit. Now, hopefully most of you guys already have your gear, but if you don't, take a look down in the description. There is a link over to Amazon, and you can hop on over there and pick your kit up. And believe me, your life and my life are going to be a whole lot simpler if we are working on identical hardware. But enough of this shameless self-promotion. Let me jump in and talk about what I am going to teach you today. And what I'm going to do is I'm going to show you my homework solution to the homework that I gave you in lesson number 38. But what I must first ask is, were you successful? If you were successful, leave a comment down below. I am legend. Double chest bump. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. So what was the homework that I gave you? Well, last week I introduced you to MediaPipe, and MediaPipe is our first real serious artificial intelligence model. And I introduced you to it last week by allowing you to use MediaPipe to find and box a face. But how did we do it? Well, let's switch on over there. Let me start by getting out of your way. Let me have a sip of my motivational elixir. And let's come over to our Raspberry Pi desktop. And this is the code. You can go to www.toptechboy.com, go to AI on the Edge with Raspberry Pi 5, come down to lesson number 38, and this was our code. We'll go ahead and snag our code, and then we'll come over to Thani. And this is a big mess. Let me just kill that. And then I will open a new window, and then let's paste that code in. And then I'm going to go ahead and save this as lesson number 39. So just so that as I update it, I will have our work here saved as lesson 39 program. Okay, so how did this program work? We basically had a face finder that we created using the MediaPipe library, and then we also had a drawing tool that's an MP solution, which we called MP Draw. And then in the real action of the program, it was pretty easy. We passed it our frame, and we got our results. And then we stepped through the results, and if there was a face in there, it would box it and do other things. Now, what is the problem? All the work is being done by MediaPipe. What's the good news? That makes it easy for us. But what's the bad news is, what if we don't like the shape or color or the way the box is done or what's it doing? We have to go in and learn every single thing about MP Draw to get it to do what we want it to. So what we really want is we want those raw results from results, and we can do the decorations ourselves using cv2.rectangle or something like that. Or if we want to take other action, we want to have that data of what is the location of the faces and the other data that's actually inside of results. So what our job is to take this results today and try to get useful data out of it. Now, I'm going to show you the way that I do that because I don't know what the data structure is. And as we go through MediaPipe, many times we're going to have different data structures. I'm going to show you sort of a methodology of going in there and seeing seeing if you can find and pick out the useful information in the results that you get back from your MediaPipe object. And so let's just run this as it is to begin with to make sure everything works, and hopefully it will work. Let's see here. Okay, boom, there it is. It's finding things. That's good. What I don't like is I have it set on my little camera down here, the version 2 camera, right? I'm running 2 cameras, so I need to tell it that I want to use camera 1, which is the old camera. And then also camera 1 is upside down, so I need to take the comment off of this so it flips it up. Now I should get good old-fashioned camera 1, and it should be right side up. So let's see. Okay, there it is. Boom, we're working at a whopping 33 frames per second, and so that is good. We're working at full speed, doing 1280 by 720 inference, so that's good. Okay, so what is the first thing that I want to do? Well, I'm just going to comment this out because I don't want it to do the drawing for me anymore, and so I'll just give it a pass here just so the program doesn't crash. First thing I want to do is just print results and see if by printing results I can see anything, like maybe I'll see a JSON file or something. So what I'm going to do is I've got results, and then I'm going to print results, and maybe it will show me a data structure that I can then start working with. So let's try that. Okay, let's look at Thonny. And what's the problem? It just says it's giving me the results as a class MediaPipe Python solutions-based solutions outputs. And so it looks like it's giving me some sort of class or some sort of strange data structure that isn't very useful. But if we look at the little sample program that we had, it seems like where the interesting stuff is, the interesting stuff seems to be in results, right? It seems to be in results. I'm sorry, it seems to be in results.detections. And so results prove to not be useful. So let's see if we can just crack the thing open where we can see what's going on in there. And instead of printing results, we're going to print results.detections. So let's see, I'll come up here and I'll just say print results.detections. And let's see if we see anything interesting there. Okay, that did not really give me anything very useful. Okay. Oh, it says none, so maybe it's not seeing my face. Okay, now once it sees my face, it gave me some data. Okay, so why was I getting none up at the top? Because my face wasn't in there. So what results.detections was returning, it was simply nothing because there was no result. But now let's look at this. We've got a whole bunch. I'm trying to see, this looks like kind of the beginning of it. So that has a label ID. Okay, that's interesting. And then it has a format relative bounding box. That looks kind of interesting. So let's see if I could look at that. Okay, and I'm going to go down in here in the part where it actually sees. I should have put it down here to begin with, and it would only print if there was something there and not a none. So that was no good. Undo. Okay, and then what I'll do here is if there is a result, then I will print results.detections. So this should only print if it sees a face. So let's look at that again, see if that's operating like what I thought. Okay, I'll quit and look at this. Okay, so this seems to be where the whole data structure is starting. There's some sort of label ID. I don't know if that maybe is like your zeroth face, or maybe this would go 0, 1, 2, 3 if you had multiple face is, I don't know. I don't need to know that yet. But what it seems to have here is there's something called relative bounding box. And so maybe that is the key to get to this data. And so let's try that. And what I'm going to do is I'm going to go ahead, and since this could have multiple results, I'm going to put it here. So let's just see if I can print detection, because the detection is going to be results.detections. It's just going to step through them. So here I should get the same result as before if I'm thinking about it right. Okay, we got a face. I'll turn it off. And then I'm looking for something that looks like the start. So again, label ID. I don't know what that is. The score would be that it's 80% sure that I'm human. That is a little bit consoling to me, that I'm not so misformed that it doesn't recognize me as a person. It's 80% sure that I'm humanoid. And then I've got this index here. So I kind of wonder if I can do something with that. I'm getting a little bit of glitch here, so I'm seeing a glitch that you guys aren't seeing. So what I want to do here is I'm going to print, instead of detection, detection.relative bounding box, like that. So you see what I'm trying to do is I'm trying to peel back this onion to get down to this data, which is giving me X men, Y men, width, and height. And that sort of sounds like kind of like what I would need to put that box on it. So let's try this. Okay, so it didn't like that as an index, all right? And so I think I will take this out and I'll look at that data structure again. And it sounds like I'm just groping in the dark, because I am. I've got a data structure. I don't know what it is. And so I've got to unwind it. Okay. So this thing that says format is giving me a format, but maybe the actual index is this. Okay. So let's come here. And what I am going to print is I'm going to print results detection dot relative bounding box, like that. Now let's see if we start printing out something that looks like this. Give it a face up. What was that? Detection, and this should have been, yeah, relative bounding box. Man, I was sure that's what I saw. So let me just print. Oh, I must not have read that right. So let me just print. Let me do that, because I might need that. It might be close. And I'm just going to print detection like that. Okay. Relative bounding box. That looks good. But look at this. Okay, between the upper level and where I am, there is a label location data. So maybe it's location data and then relative bounding box. So let's try that. And guys, if you're frustrated because I'm just kind of bumbling through this, I'm showing you that to take these things apart, you have to kind of bumble through them. So I think maybe location underscore data and then dot relative bounding box. So I get to this part of the data structure by the key location data, and then I get through this part of the data by this. And so if I want to dot this, dot that, I need to dot the part that is before the open curly. Okay, so now let's try it. Let's give it a face. All right, let's quit. Look at that. So what do I have? I have an X-min, Y-min, which is probably the upper left of the box, and then I have a width and I have a height, and that would give me the other corner, or it would give me the center of the box. That is really good. What do we see here? The numbers are between 0 and 1, and so I think it must be giving me X-min, Y-min, width and height as a fraction of my overall total frame width and height, which is my uppercase W and my uppercase H. All right, so now we're just going to take this nonsense out because we are making some progress here. Okay, we are making some progress. So let's see what happens. Let's see what happens. So what I'm going to do is I'm going to comment this out for right now. And what I'm going to do is I'm going to see if I can get my X equal, right, just like we've done before, Y equal, and then my, whoa, what happened there? I must have paged up or something, yeah. And then I'm going to get my width of the bounding box, and then I'm going to get my height of the bounding box. And let's make this a little more readable like this. Okay, the X is going to be, now what is the index here? The index is X-min. So I think what I'm going to do is I'm going to go ahead and I'm going to see if I can just grab that data structure to make it a little bit simpler. So I'm going to create something called B box. And that's going to be equal to detection.location underscore data dot, and I'm going to copy it from up here because that will be easier. Like that. Now this B box, it's going to be easier for me to work with B box as I go B box this, B box that, than having to put this whole thing in over and over. And even if I copied and pasted, it would be kind of hard to read code. So now what would my actual X be? It would be B box dot X-min. How do I know that? I see X-min here. Now the problem with that is that would just give me that fraction. What I need to do is I need to multiply that fraction by my width of my whole frame, and that is definitely going to be a fraction, and you know that we're going to want an integer of that when we work with openCV. Okay, now I think we can take this and the Y value would be Y-min, and then this would be, what would that be? That would be the, what would our keyword be? Width. Width. And then this would be what? I see the key here is height. Okay, guys, tell me, did I just totally confuse you, or did I show you how you can take a data structure you're completely blind to, and you can poke around and you can pull out of that data structure the things that you want? Let's just run this to make sure that it doesn't crash. Let's give it a face. Okay, it's happy, so at least it thinks that it has those values. What can we do now? We should be able to CV2.rectangle. What do I want to put the rectangle on the frame? And then I'm going to go ahead and make this a multi-line piece of Python code by just hitting enter. And then where do we want to put it? At the tuple X, comma Y. That's the location. You guys know the rectangle command already. Now, where is the lower right corner? It would be at X plus little w, right? Little w, which is the width of the box, comma Y plus little height. Now we've got our position, And now we need to give it a color. And so our color, I'm going to give it yellow. So that would be blue 0, 255 for green, and 255 for red. Okay. Now I need to give it a width. And that width, I think I'll make 3. And if I'm not mistaken, that's everything we need. And I'm hoping that will give me a yellow box. No attribute, rectangle. Rectangle. Let's try that again. Okay, now I've made a mistake. But at least it's drawing a box. So where did I make my mistake? X-min times W. B box would be Y-min times H. I forgot about these. The box, B box width would be times W, and the box height would be times H. Just copying and pasting. I didn't make those corrections. Let's see if it works this time. Boom, look at that. 33 frames per second. I am doing the decoration myself, not using their little cheater codes. All right. So guys, I hope you don't get mad at me for what I just did, because I can't say you do step 1, 2, 3. We've just got to get that data structure it sent us and then try to break it apart. Now, somewhere deep down in the documents and all of that, probably this is documented somewhere, but I find that I can figure these things out faster than I can find the documentation for the whatever particular version of openCV that I am using. So I have found that to be very, very useful. Now, what is the thing that we also saw? I'm going to go back, and this time I am going to print detections. Okay, so I'm just going to go back and see, is there other data in there? Okay, so we've got the box, so that's pretty exciting. And so now I'm just going to look at that data structure and see if there's anything else in there. What did I do? For detection, singular. Okay, now I'm going to quit. Now let's look and see if we can find what we're doing. So I've got my object, and then I've got the dot location data, and then I've got the dot bounding box, and then I've got the dot xmin, dot ymin, dot width, dot height. So I have dealt with this part of the data, but then there is another location data dot what? Relative key points. Relative key points. And how many are there? 1, 2, 3, 4, 5, 6. Now, what are those probably? Those are probably the location of the eye, the other eye, the ear, and the mouth. Now, we don't know what order they are in right now. We don't know what order they are in right now, but what we know is we know we can get to them. Okay, we can get to them. And let's make sure I want to still be here. Yeah, this is going through the detections. So what I'm going to do is I'm going to say the key points. I'm going to get like a list of key points, and those are going to be detection. And then who's your friend? Location underscore data. And then what are they called? Relative key points. So relative underscore key points, like that. Right? Now, let's just see if we can print key points like that and see if we've got something we can do something with now. And I'm going to take this print out because it's just, it's going to be too much stuff going by. So let's print, or let's run. Okay, look at that. So what I have is I have open a list, and then I have an X and a Y, and then an X and a Y, an X and a Y, and an X and a Y. So you see, it's like I've got XY and then comma the next XY. So now I want to what? I want to step through those. So let's see if we can step through them. I came into the code in the wrong spot. I'm going to come back to key points. I don't want to print key points anymore, but I'm going to see if I can step through key points. So I'm going to say for KP singular in key points, and then what if I just print KP? So you see, I'm going to see if I've got, like, I'm peeling the onion back. So let's try this again. Okay, now what I have is I have X and I have Y. So I should be able to just do KP.X and KP.Y. All right. So what I'm going to do is I want to put a circle at each one of those key points. So then I could say, well, I could say KP.X like that, but that's not going to be very useful. So I'm going to create KP X, and that's going to be the integer value of kp.x. That's the actual data times the width. And then kpy is going to be equal to the integer of kp.y times the height. And right, these are relative to the whole frame, not the small frame. So you've got to keep track of whether you're using the uppercase W or the lowercase w. All right. Now what could I do? CV2.circle, and where do I want to put the circle? On the frame. Okay. And then where do I want to put it? At the location. Remember, location is a tuple, kpx, comma, kpy, like that. Don't forget your comma. I did not like those itty bitty little tiny dots, and so I'm going to put some beefy dots. I'm going to make my dots a radius of let's say 15. Okay. Now what color do I want? I want blue. So I'm going to give it the tuple 255, 0, 0, and then I want them to be solid, so I'm going to make it -1 like that. And now I am going to run this thing. Boom! Look at that. Who's decorating the frame? I am. Look at that. Look at that. Now, also, what do you know? Even with me busting that results thing up and decorating myself, we are still operating at 33 frames per second. So let's see if we can quit this thing. Okay, and it seemed to quit cleanly. That's good. So now, what else should I do? That is pretty good. What I want to see is I want to see how fast this thing really is. So I'm going to come over to my camera that'll actually operate at 50 frames per second. And then I'm going to come up here and I'm going to change it to camera 0. And then I'm going to see what happens if we can actually run faster than 33 frames per second. All right, so let's run that. Okay, and that one's upside down, so I've got to come over here and I've got to not flip my frame. All right, so now let's run it. Okay, boom, look at that. We're running at a staggering 49 frames per second at 1280 by 720, and that is absolutely amazing. Let's see how fast we can go if we make it 1920 by 1080, like that. Look at that. We are still operating at almost 30 frames per second. 30 frames per second at a full high resolution image, and still you can see I didn't shave this morning. That's how clear the picture is. Okay, and we're doing that at 30 frames a second, doing a full facial inference and finding points of interest, landmarks on the face. So that is absolutely pretty amazing. We're going to go ahead and change that back to 1280 by 720, and we're going to go ahead and change that back to camera number 1. Okay, and I'll run it just to make sure that things are working. Got to flip it back. That is so annoying that my one camera is upside down, and then it causes me this endless grief. But let's see now. Back to the old camera. Okay, boom, look at that. Now, at this point, what I hope you see is because we just bit the bullet, we ate the pain, and we figured out this results data structure. Now we have the data, we have access to all the data, and all of those things that we did before, we can do those again because all of those methods that we learned, we just needed the X, Y, W, and H of the bounding box. And then now we have all this bonus data of the key points. So if there was something particular about the nose we were interested in, we know the location of the nose. Okay, guys, I hope you weren't frustrated with what I showed you today. I hope you were not frustrated with what I showed you today, because it allows you now, when we go in and we do hand recognition, that we'll know how to just take a results from the hand finder and how to figure out what's what. And so for the remainder of our MediaPipe portion of this class, you're going to know how to do it. And so if you got a little lost, go back and watch this video again and kind of do it step by step. Okay, this is your homework for tomorrow. Okay, or for next week. And what you're going to do is, do you remember that program that we had back on, what was it, lesson number 34? Or let's see. Yeah, it was lesson number 34, where we were tracking the face, but we were finding the face with the hard cascades. But now I want you to redo this lesson. You can start with this lesson number 34, but instead of doing these hard cascades, what I want you to do is to use the MediaPipe finder. And what did you see? You saw that it runs about twice as fast using a modern state-of-the-art model, MediaPipe, as compared to those old hard cascades. And show you what you need to do.
Hello, I am ready to eliminate humanoids. Humanoid detected. Shall I track?
Track. Release. Blind.
Subject has been blinded. Shall I vaporize?
Restore.
Subject sight has been restored.
Track. Blind.
Subject has been blinded. Shall I vaporize?
Restore.
Subject sight has been restored.
Release. Quit. Quit. Okay. All right. So anyway, that kind of shows you what we're trying to do. And it's a little bit of a fun project. And it's very similar to lesson number 34, with the main difference being that we're going to MediaPipe instead of the hard cascades. And then we're adding that additional level where we can actually blind our tracked humanoid if we want. Okay, guys, I do hope that you are having as much fun in this class as I am. It is at this point that I always give a great big shout out to my Patreons. Without the encouragement and the financial backing of my Patreons, I would not be able to continue to produce quality, fresh, in-depth content every single week. So a big thank you to you guys. You can help this video by giving it a thumbs up and leaving a comment down below. If you haven't already, subscribe to the channel. And when you do, make sure you ring that bell so that you'll get notifications when future lessons drop. And most importantly, share the video with other people, because the world needs more people driving the AI and fewer people getting run over by the AI. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.